Aviation gasoline, or Avgas, is a specialized fuel for aircraft with spark ignition engines. These engines, found in smaller aircraft, rely on Avgas for power and performance. Like cars need gasoline, these aircraft need Avgas to fly. Avgas is formulated for flight conditions, ensuring reliable engine operation. It meets stringent quality standards to guarantee performance and safety. Using the correct Avgas is critical for safe and efficient flight. Today, several types of Avgas are available, each with its own unique characteristics and intended applications. These variations are primarily defined by their octane rating, which indicates the fuel's resistance to detonation or knocking. The most commonly used Avgas today is 100LL, which stands for 100 octane low lead. It is dyed blue for easy identification. Another type of Avgas gaining popularity is UL91, which stands for unleaded 91. It is dyed purple and is lead-free. Lastly, G100UL is a new unleaded Avgas with an octane rating of 100. It is dyed green and is intended as a direct replacement for 100LL. The use of lead in Avgas has been a topic of debate for many years. Tetraethyllead, the lead compound added to Avgas, is a highly effective anti-knock agent. It allows engines to operate at higher compression ratios without experiencing detonation, leading to increased power output and efficiency. However, lead is a known environmental pollutant and poses health risks to humans and wildlife. Leaded Avgas emissions contribute to air pollution and can contaminate soil and water sources around airports. The aviation industry has been actively researching and developing unleaded Avgas alternatives to mitigate these environmental concerns. Unleaded Avgas types like UL91, UL94 and G100UL offer a cleaner alternative to leaded Avgas. They provide similar performance characteristics without the harmful effects of lead. However, the transition to unleaded Avgas faces challenges, including compatibility with older aircraft engines and the availability of unleaded fuel infrastructure at airports worldwide. The debate over leaded versus unleaded Avgas involves balancing performance requirements with environmental responsibility. While leaded Avgas remains the most widely used type today, the industry is steadily moving towards a future where unleaded Avgas becomes the standard, ensuring cleaner and more sustainable aviation practices. The evolution of Avgas has mirrored the advancements in aircraft engine technology throughout history. In the early days of aviation, lower-octane fuels like Avgas 80 were sufficient for the less powerful engines of that era. However, as engine designs improved and power outputs increased, higher-octane fuels became necessary to prevent detonation and ensure reliable engine operation. Avgas 100, a leaded fuel with an octane rating of 100, emerged as the dominant Avgas type for several decades. It provided the necessary knock resistance for the more powerful piston engines that powered aircraft during that period. Avgas 115, with an even higher octane rating of 115, was also used in certain high-performance military aircraft. However, as concerns about lead emissions grew, the aviation industry began phasing out Avgas 100 and Avgas 115 in favor of lower lead alternatives. Today, these higher lead Avgas types are no longer in production or readily available, highlighting the industry's commitment to reducing the environmental impact of aviation. The historical progression of Avgas demonstrates the continuous adaptation and improvement of aviation fuels to meet the evolving needs of aircraft engines and address environmental concerns. Ensuring the use of the correct Avgas type for a particular aircraft is paramount for safe and reliable flight operations. The Pilot's Operating Handbook, or POH, for each aircraft specifically states the approved Avgas types for that aircraft model. It is the pilot's responsibility to carefully consult the POH and adhere to the manufacturer's recommendations regarding fuel usage. The POH provides crucial information regarding the engine's fuel requirements, including the permissible octane rating, lead content, and any other specific fuel specifications. Using the wrong Avgas type can have severe consequences, ranging from reduced engine performance and efficiency to engine damage and potential engine failure. Pilots should always verify the Avgas type being dispensed into their aircraft and double-check the fuel truck and fuel pump labels to ensure they match the POH specifications. In case of any doubt or uncertainty, pilots should consult with a qualified aircraft mechanic or fuel supplier to confirm the correct Avgas type. Fueling an aircraft is a critical aspect of flight safety, and adhering to the POH's fuel requirements is non-negotiable. By following these guidelines, pilots contribute to the safe and reliable operation of their aircraft and ensure a safe and enjoyable flying experience. The aviation industry recognizes the need for more environmentally friendly Avgas options and is actively pursuing the development and implementation of sustainable alternatives. Research and development efforts focus on unleaded Avgas formulations that can match the performance of 100 low lead or 100 LL while minimizing environmental impact. Several promising unleaded Avgas candidates are currently undergoing testing and evaluation. These new generation fuels aim to provide equivalent or better performance compared to 100 LL, ensuring compatibility with existing aircraft engines while reducing or eliminating lead emissions. The transition to unleaded Avgas requires a collaborative effort between fuel producers, aircraft manufacturers, regulatory bodies, and airport authorities. Infrastructure upgrades at airports are necessary to accommodate the distribution and storage of unleaded Avgas, and aircraft engine modifications may be required to ensure compatibility with certain unleaded fuel types. The future of Avgas is undoubtedly headed towards a greener horizon. The aviation industry's commitment to sustainability is driving the development and adoption of unleaded Avgas, paving the way for a cleaner and more environmentally responsible future for aviation. Avgas is an indispensable element of piston-engine aircraft operations, providing the energy needed for these aircraft to take flight. Understanding the different types of Avgas, their characteristics, and their impact on both engine performance and the environment is crucial for all stakeholders in the aviation industry. From the early days of Avgas 80 to the widespread use of 100 LL and the emergence of unleaded alternatives, the evolution of Avgas reflects the continuous advancements in aviation technology and the industry's commitment to sustainability. As we look towards the future, the development and implementation of unleaded Avgas will play a pivotal role in reducing aviation's environmental footprint while ensuring the continued safety and efficiency of piston-engine aircraft operations. The safe and responsible use of Avgas is a shared responsibility among pilots, aircraft owners, fuel suppliers, and regulatory bodies. By working together, we can ensure that Avgas continues to fuel our passion for flight while minimizing its impact on our planet.